right, looks like I got two people out there waiting, so what are your questions? By the way, there's like a 30-second lag between when I say something and when it appears on your screen. So if you're curious why it takes me so long to answer your question sometimes, it's probably because there's like this lag. Oh, hi. Swoop. I know. So for 252, there's no pre-lab work due next week. We're just going to show up. We're going to go over how to use the equipment, go over how to use the glassware, and we'll review IR, NMR, mass spec, and a little bit about naming and chirality, just in case there are any questions. But other than that, no pre-lab. Just show up. It's purely review. I'm going to take attendance while we're in there, and that's going to be that. Yeah, so as far as the practicing goes, all it's going to do is record a video of you taking your exam. Big thing is just making sure that your emotions kind of match up with you taking an exam. Um, so yeah, if you're taking your exam as normal, don't worry. It's just there to keep the honest people honest. The bigger thing is more like if I go back through and look through the video and you seem to be you're answering questions, but you're not moving anywhere. Like you're not moving the mouse, you're not typing on the keyboard, and somehow you're answering questions. That's the bigger thing. All right, no more questions? More work on the banjo. Is everything done through the website, or do we need to download a lockdown browser? Everything is done through the website for the exam, so basically it should provide you with any downloads you need. The browser lockdown is just going to limit you to one tab, and I think there's some way, I'm not even going to pretend to understand the technical details of it. But everything you need to know is going to be available. Everything you need or need to know is going to be available on the Connect website when you go to take the exam. Can we go over how electron donating electronic probes affect the basicity of a compound, like on problem 6 in Connect? So let me bring up, this is for Organic 2. Let me bring up the homework. So this question is actually both a review and a preview of Organic 1 as well as Organic 2. So you're given 3 anions. Yeah, you too, Lauren. I'll see you next week. So what we have going on here is an equilibrium, and the question of whether or not something is a good base is a reflection of how good of an acid was it started with. So if we look at the acid reaction, the question is if we add water back to it. Actually, no, let's just do the H pluses. Make sure you can actually see this. Yeah. So if we add the H plus, the question is which way does this equilibrium lie? So So off the bat, you should remember from Organic 1 that the acidity of alkanes is like negative pKa. Like they do not give up hydrogens. This is part of the reason why they're so unreactive. So since this reaction really does not lie anywhere to the left, this makes this the best base. Now, the reason it's the best base is that it is near impossible to withdraw a hydrogen off of a carbon-hydrogen bond. So that's what I mean by this is kind of review. Now, all of these anions are resonance stabilized, but the question is how many of these are just like good acids or bases on their own? Now, another thing to remember from Organic 1 when you worked with alcohols here is that this hydrogen is actually participates in hydrogen bonding. So alcohols here, from the IR, if you look at the IR in that 3600 wave number range, we end up getting this big broad peak due to the fact that these hydrogens do exchange. So alcohols on their own are actually pretty good at losing their hydrogens. This is where hydrogen bonding comes from. So this ends up being your weakest base. So the nitrogen here is kind of the one that sits between the two. Now, it is somewhat stabilized, and ammonia does actually end up losing a little bit of hydrogen. You can do this. But the other thing to keep in mind is that ammonia is actually a better base than it is an acid. So if we do an H+, we can get the ammonium complexes, so that NH3+ that we saw from actually general chemistry as well as organic chemistry. So your ammonia here is going to sit between the two. So that's what I mean, that this is kind of a review back from Organic 1. You can kind of derive it off of it. You can also go look up this information, but a lot of it is just making sure you remember these concepts back from Organic 1. Organic 1, alkanes don't lose their hydrogens at all. So this reaction clearly sits to the right, so this would make it a fantastic base. Alcohols do participate in hydrogen bonding. This is why we get this bending mode in the IR. So we expect this to actually be a weaker base because it can go back and forth. And the nitrogen here is going to sit between the two because it's an amphoteric material. It can accept both hydrogens and lose hydrogens. Other questions? So electron donating, electron withdrawing, not the best tables to use for it. Their acidity is more a reflection of the functional group than it is. That said, you can go look up tables of pKa's and pKb's of these compounds. So phenol, aniline, and toluene. And those tables would also kind of give you that information. So if you look at the pKa of toluene, it's probably like super, super, super positive. Whereas something like phenol is going to be, if not negative, very close to zero, and aniline is going to sit somewhere between the two. Their ability to electron donate or withdraw is a reflection of two things. One, can it undergo resonance with the ring? The second is how electronegative is that element. So typically if we have an element other than carbon or hydrogen bound to the ring, it's going to be, particularly one that's more electronegative than carbon, it's going to be electron withdrawing. There are exceptions. Right? the third question in the discussion board for Organic 1. All right, let me bring up the discussion board for Organic 1. So the third question is asking about the RS symmetry of this molecule. It numbers the carbons for you: 1, 2, 3, 4, 5, and 6. Now, a mistake a lot of students try to make with these structures is they assume because they see a wedge or a dash, it must be a chiral center. That isn't true. In order for an atom to be chiral, it has to meet the condition that the 4 groups attached to it are different groups. So if we look at carbon 1, obviously they're not all different groups because we have 3 hydrogens, so this is not a chiral center. If we look at number 2, we have a CH3 and a CH3. These are 2 the same, so that's not a chiral center. CH3 down here is not chiral. This CH2 has 2 hydrogens, they're not chiral. If we look at this one, we have a CH3, we have a hydrogen that sticks off to the back, we have a CH, CH3, CH3, we have CH, CH3, CH2, CH3. So this ends up being a chiral center. And if we look at this one, it's the same thing. We have 4 different groups. So there's really only 2 chiral compounds in the chiral carbons in the center. So the next thing is to set the priority rules. So if we set the priority rules, we look at what's bound around this carbon. So we've got a carbon, and attached to it is a carbon, 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 and a hydrogen. So this hydrogen here is the lowest priority, so we'll give it rank 4. If we look at the carbons that are attached to it, this carbon has 3 hydrogens. This carbon has 2 carbons and a hydrogen. This carbon has 2 carbons and a hydrogen. So since the hydrogens weigh less than the carbon, this ends up putting this at a lower priority of 3. If we start working our way out, we basically, the quick way to do this with alkanes is look at the size of the chain in the branching. The longer and the more branched the chain the more likely it is high priority. That said, you can prove it if we look further out. These carbons are each bound to 2 hydrogens. This carbon is bound to 3 hydrogens, but this one's bound to a carbon and 2 hydrogens. So this ends up being top priority, and this ends up being second priority. Now, there are 2 ways to figure out the R and the S configuration in terms of practically how you do it. What you're looking for with R or S is that we want to take the lowest priority group and we want to turn it back. And we want to look down the carbon so that 3 groups are pointing back at us and our lowest priority group is pointed behind the carbon. So if we end up in a situation where our groups go clockwise, so it may not necessarily be 1, 2, 1 at the top, but we can definitely see this clockwise rotation. Clockwise rotation is an R. Counterclockwise, 1, 2, 3, is going to be S configuration. So when I say there's 2 practical ways of doing this, the best way to do this is actually use a modeling kit. So these are going to help a lot with trying to figure out the actual stereochemistries and things like that. So let's build it really quick. 2, 4, 6. Oh good, I already have one of those put together. So this is the molecule that's in this drawing here. I'm going to swap this out with a yellow atom just to make it a little bit easier to see which ones we're focusing on. So this is carbon number 3 here by that schematic. Sorry. So the lowest group here is the hydrogen. So if we turn it to the hydrogens back, this is the highest priority group. So we got 1, 2, 3. This is counterclockwise. So if you're looking down at this position, it goes 1, 2, 3. That's counterclockwise. So this gives you an S symmetry here on the third carbon. So this would be a 3s molecule. Same thing is going to apply when you start looking at this one. It isn't necessarily RS, so I'll leave it to you to figure that one out. But it's the same process. You need to go over here. Doesn't matter what work you did over here to find this one. Find the priorities of each of the groups. The hydrogen that's bound to this is obviously lowest priority, so it's 4, but you need to figure out which of these branches is higher priority. And then take your molecule. Come on. Align it so that hydrogen is pointed back at you or pointed away from you. Figure out which way it goes, clockwise or counterclockwise for the priority groups, and that'll tell you if it's an RS symmetry. Now, I will give you fair warning. Alkanes are the absolute hardest for assigning R and S because there are no heteroatoms. It's all carbon and hydrogen. So when we do naming of alkanes for the test 2 material, and there's that R and S in there, it is hard. It's going to get easier. So if you can do R and S for a pure alkane, you can do R and S for alcohols, alkenes, whatever else. It's super easy. And these CIP rules, the Cahn-Ingold-Prelog priority rules that you're using to assign these R and these S, they do come back not only for R and S for later molecules, they show up for alkenes when we do easy notation. So the rules you're learning right now for assigning priority, they're actually going to show up for the rest of the course. You're welcome. Any other questions out there? they're at work. Pick them up next week. Homework problem 38 on test material is giving me some trouble. All right, let's take a look at, this is organic 1. Problem 38, give me just a minute to bring it up on this laptop. All right, draw the three-dimensional representation of the S enantiomer shown below. So the first thing to do is identify the chiral center. So here we have a difluorocyclopropane. Don't worry, at this point you should know how to name that. So we've only got 3 carbons here that actually have, oh, this one's super easy actually. Okay, so best advice for you is to actually build the molecule, and you'll see that there's really only one way to put this thing together. Sorry, this looks a lot harder at first. So your cyclopropane has to be a triangle like that. We're going to let the CH3 group be the methyl group, and then our difluoro, yeah, we'll use blue. Now there's only one chiral center in this whole molecule, and it's this one here. Now they've got it drawn like this. So your hydrogen goes up, your CH3 group goes down, you've got the 2 fluorines. You do want to verify that this is the S enantiomer. The hydrogen is the lowest priority, so it's going to go in the back. That's highest priority 1, 2, 3. Since this has a carbon with 3 hydrogens, actually no. 1, 2, 3. Yeah. So 1, 2, 3, that's going to be counterclockwise. So this is the S enantiomer. Now, as far as drawing it, if I remember correctly, this one's really picky. So the way you're going to draw it is that solid bond there in the back is the only line that there is. So if you look at it like this, you need to draw the 2 carbons coming out as wedges and everything else going back as a dash. It is oddly picky about this particular problem. It's not wrong per se. It would just be easier if you drew it like that and had the CH3 going out, the hydrogens going back, and 1 fluorine going back, and 1 fluorine going forward. So I would agree with you. This is correct. It's the same structure, but the way this is keyed, let me just make sure that's true. But I remember this having an issue last semester. Really? Apparently it's accepting this answer now too. So this is the correct answer. So are you getting a structure that looks like this? You've got the CH3 group as a wedge, the fluorine is a wedge, 1 fluorine is a dash, and 1 hydrogen is a dash. Well, it would help if I actually named the structure correctly, wouldn't it? Sorry, I do want to check it on my end just to make sure it's not some bug with the program. So for me, it's even accepting this turned at a right angle. My best guess that it's just more of an issue with how it's being put into the editor itself. So conceptually, you seem to understand it if you're getting this answer. It's just something about how it's being inputted into the editor itself. So the best recommendation I have is send me a screenshot of what you have, and I can take a look at it. Probably won't get to it this weekend, but definitely next weekend I can take a look at it and see if there's anything weird about what's drawn. Okay, good. All right, so we've reached the end of the live stream. Again, reminder, Monday we do not have lab because it's a holiday. We also don't have anything due. So enjoy your weekends, and I will see you all next week. Several of you, or especially Organic 2 people, I will see you in person.